Okay, so in these sections, or this section specifically, we're going to choose the appropriate method to solve a system of equations. So it's either going to be substitution or elimination. They're not giving us graphing as a method, although that can also be used. It's a very effective method depending on how the problem is set up. So we're going to take a look at what we see and which method makes the most sense. So this is applying those systems that we learned in the last couple of sections. If you have not gone through that homework, or if you've not watched the videos for substitution or elimination, definitely go back and take a look at those so that you kind of review and you know how to choose and then how to apply. So solve the following system of equations. So I can see 3x plus 6y equals negative 9, negative 3x plus 2y equals 17. So in this case, since the 3x's match, elimination with addition is the best choice. I don't know if I'd say best choice, but it's the easiest choice, right? Because I already have 3x and a negative 3x. If I add straight down, 3x plus negative 3x is 0. They already eliminate. They cancel out. So that's why I'm saying that's, the best choice. It's the easiest one to go with there. So if we add straight down, the 3x's cancel, and I get 6y plus 2y is 8y. Negative 9 plus 17 is positive 8. Since they're opposites, I'm going to subtract, but the bigger number is going to tell me, what my sign is. It's a positive 8. And then I'm going to undo that multiplication with division. 8 divided by 8 cancels out. So I have y, 8 divided by 8. And again, it cancels out, but it becomes 1. We can't just say it's, gone. There's nothing there. It's a 1. Technically, there's a 1 in front of the y as well. We just don't put it there. All right, remember, you're not done yet. This is one part of the coordinate. In a coordinate plane, we have x and y because we're moving two-dimensionally. Okay, so this is one dimension. I need my second dimension in order to know where they actually cross. So I'm going to choose one of the two equations. And in this case, I'm choosing the first one. Doesn't matter. I could have chose the second one. I'm choosing the first one for whatever reason. And I'm going to plug in y. So I have my 3x plus 6y equals negative 9, but I know y is 1. So I'm going to plug 1 in, and then 6 times 1 is 6. So now I have 3x plus 6 equals negative 9. I'm going to go ahead and solve for x. So I'm going to subtract 6 from both sides. So I'm undoing that plus 6. And then I have 3x drop down. 6 minus 6 cancels out. Negative 9 minus 6 is negative 15. And now I'm going to undo that multiplication with division. So 3 divided by 3 cancels. Negative 15 divided by 3 is negative 5. So now I have my full coordinate. Remember, you need to have both parts in order to finish the question. Because just y equals 1 is not the answer. I need both what is x and y so I can actually plot that point if I wanted to see where those two cross. All right, let's go ahead and try another one. So solve the system of equation. And again, since each equation equals y, I'm saying substitution is the best choice. So we had quite a few of these in the substitution section where if I know y equals 6x plus 5 and y also equals 8x minus 7, well, I know y equals y. So then the expression 6x plus 5 must equal 8x minus 7. I can just substitute the two pieces together because they both equal the exact same thing. They both equal y, so they must both equal each other. Okay, so this is just one of those special situations where we can use substitution if we have slope-intercept form. These would also be fairly easy to graph as well if we wanted to use that system. They just don't provide you with graph paper, so you'd either have to use an online graphing calculator or, an actual graph paper, which you should have, available at your school if you need it there. So I'm going to go ahead and choose when I have the situation where it's a variable on both sides and a constant on both sides. I'm just going to choose something to start moving because I want to start combining like terms. So I'm going to subtract 6 from both sides. I tend to start with variables, and I always move in a way that's going to give me a positive number or try to move in that way. So that's why I'm subtracting 6 over to the right side. So my 6 minus 6 cancels. 5 drops down. 8x minus 6x is 2x, and then the negative 7 drops down. So now that I have x, all my variables, my x is on one side, I'm going to go ahead and start solving for x. So I'm going to add 7 to both sides. Oh, that animated out of order there. So that I'm going to add 7 to both sides. So I have 5 plus 7. Well, that's going to give me 12. The 2x is going to drop down. Negative 7 plus 7 cancels out. Now I'm going to undo that multiplication with division. So 2 divided by 2 cancels, it becomes 1. 12 divided by 2 is 6. So 6 equals x. Remember, that's half the solution. Now I need to go back and I'm going to choose either one of the two equations. So I'm choosing the first one again, and I'm going to plug in x, 6 for x, because I know what x equals where the two equations cross. So 6 times 6 is 36. 36 plus 5 is 41. So my solution is 6, 41. And if I put this in a coordinate point, I would be, with parentheses around it, I'd have 6, 41. And this one would definitely be a little harder to graph because that 41 is usually much farther off the graph than they ever give us. Usually the farthest we can go is about 12 instead of 41. So that one would be a little bit more difficult to graph. All right, let's go ahead and do one more of these. So negative 5x minus 6y equals 14. 2x minus 3y equals 16. So with this one, neither one of them match. 5 and 2 don't match, 6 and 3 don't match, but I can easily turn 3 into 6 using multiplication. So in this case, I'm choosing elimination, but I have to use multiplication before I can get there. So it's elimination with multiplication. So you can see I already put the first equation here. The second equation, I'm going to multiply by negative 2 because I want to change this negative 3y into positive 6y. That's my goal, but I have to multiply everything else within the equation in order to get there. So 2x times negative 2 is negative 4x. Negative 3y times negative 2 is positive 6y. And 16 times negative 2 is negative 32. And the reason I did negative 2, again, I'm going to reiterate that, is because I want these to be opposites. That way I can add straight down. If I just multiplied by 2, I'd have negative 6y and negative 6y, which isn't a huge problem, but it means I would have to subtract the 2 in order to actually get 0. And that means I have to subtract everything, and it's just a little bit more of a process. So if you always make sure that you have opposites, you don't have to worry about that subtraction problem. You can just add straight down. So negative 5x plus 4x is negative 9x. Negative 6y plus 6y, well, those cancel. That's 0. 14 plus negative 32 is negative 18. They're opposites, so I am going to subtract them. And the bigger number will decide my sign there. I have negative 18. All right, so now I'm going to undo that multiplication with division. Make sure you take the negative with it. I don't want to leave the negative with the x. So negative 9 divided by negative 9 is 1. Negative 18 divided by negative 9 is positive 2, because two negatives make a positive there. So this is half of my solution. I'm going to go and choose one of the two equations. I'm choosing the first one again. Again, it wouldn't matter if I chose the first or second one. I should get the exact same answer either way. And I'm going to plug in 2 for x, since I know what x equals. So negative 5 times 2 is negative 10 minus 6y equals 14. So now I'm going to start solving for y. So I'm going to add 10 to both sides. Negative 10 plus 10 cancels. Negative 6y drops down. 14 plus 10 is 24. So now I'm going to undo that multiplication with division. Again, don't forget to take the negative sign with it so that we just have y equals. So if I left the negative, if I didn't divide by negative 6, I would have negative y equals. Well, I don't want to know what negative y equals. I want to know what y equals. So make sure you take that negative with it. And then on the side, I have 24 divided by negative 6. So you can see that's negative 4. So my solution in this one is 2, negative 4. So this one wouldn't have been too bad for graphing because that's definitely within the graph window that we're normally given. But I would have had to change both of these. Either I would have had to create an XY table and pick some points so that I can plot the line, or I would have had to make them slope-intercept form by kind of manipulating the equations here, which I had to manipulate a little bit, but not a whole lot. So it just kind of depends. But this section is just about identifying the most appropriate system or method to use to solve the system of equations. All right, I hope that helped, and I'll see you in the next video.